Hi science students, today we're going to review for your quiz on acids and bases. So let's go ahead and get started. I've made 3 areas on my paper, one for acids, one for bases, and one for neutrals. All of this should just be review that you've already taken notes on, you've already explored, but I wanted to make a very clear itemized list for you so it was easier for you to go through and make sure that you're looking at an acid or you're looking at a base or you're looking at a neutral. So let's go ahead and get started. So first and foremost, I've got acids and bases. Something that I noticed in one of our assignments previously is that we were a little unsure of how to neutralize an acid or neutralize a base. So acids are always going to be neutralized by adding a base to them. Acids, we said, are releasing that hydrogen ion, and bases are releasing that hydroxide ion, and when they combine, they actually create water that is released. So acids are going to be neutralized by a base, and bases are going to be neutralized by an acid. That was something I definitely wanted to clear up because there was a little confusion on our assignments previously this week. So we're going to go down our column about acids first, and we're going to look just at all of the properties of acids that we need to remember when we're considering where I should identify the particular substance I'm looking at. So acids are going to have a pH that's 6 or lower. So numbers 0 to 6 all the way up to 6.9 are going to be considered acids. The lower the number or the smaller the pH, the stronger the acid is. So if I have an acid with a pH of 0 and I have an acid with a pH of 4, I know that the acid with a pH of 0 is going to have a stronger acidity than the pH of 4, simply because it's a stronger acid if it's qualified at a lower pH or a smaller pH number. It's going to turn red if I dip my blue litmus paper into it. And we're going to notice that consistently acids are going to turn things red or are going to stay red when tested. So when I test it with blue litmus paper, the paper will turn red. When I test it with red litmus paper, the paper stays red. And when I pour cabbage juice into it, it's going to turn red or it's going to turn pink, depending on the acidity of the substance. Bases are going to have higher pH numbers. They're going to have pH of higher than 8. So anything from 8.0 up to 14 is going to be considered a base. And essentially the opposite of an acid, if I have a larger pH or a higher number, I know that I'm going to have a stronger base. So my strongest bases are going to be closer to 14 as their pH, rather than closer to the neutral zone, closer to 8. So if I were to look at 2 substances, one with a pH of 9 and one with a pH of 13, I know that my stronger base would be the one with the pH of 13, and my weaker base would be the one with the pH of 9. So bases, we're going to notice, are going to consistently turn things blue. So as I use red litmus paper, bases are going to turn that red litmus paper blue. Bases are going to stay blue when I'm using blue litmus paper. And when I pour cabbage juice into them, bases are going to turn blue, green, or yellow. Yellow is going to be my strongest bases, blue are going to be my weaker bases, and green are going to be somewhere in the middle. I know that on some pH scales, neutrals are qualified as green, so you want to be really careful when you're looking at the pH scale, not to just look for colors, but more specifically look at the pH numbers, because those numbers are not going to alter, whereas the colors in the scale being looked at might be different. So lastly, let's talk about some neutrals. If a substance is deemed a neutral, it's going to have a pH of 7. The most commonly used example of a neutral is going to be distilled water, and you often will see that qualified right in the middle of a pH scale. If I'm looking at different substances and their acidity or how basic they are, neutrals are typically going to be deemed as distilled water. That's the most common example. You're going to also notice that neutrals are not going to change any of the indicators in any way. So if I'm using red litmus paper and I dip it into a neutral like distilled water, it's going to stay red. Same goes for blue litmus paper. If I dip it into blue litmus paper, it's going to stay blue. If I pour cabbage juice into it, it's going to stay the same color that the cabbage juice was. It is not going to change because neutrals are not going to do anything to alter the indicator in any way. So I'm going to leave this here. In the event that you need to pause your video in order to record this information, I would encourage you to do that. That's everything I have for you. Good luck on the quiz. Have a really good day. Stay safe. Bye-bye.